Hello and welcome to the session. My name is Ralph Fleming and I'm the Cloud Operating Model Lead for the Asia Pacific, Japan and China region. With me today is Stephanie Wynn, a Senior Customer Solutions Manager with a background in cloud operations. We're both based in Sydney, New South Wales. Now, from our experience working with customers across the region, we find it's often the organisational rather than the technical aspects that pose the greatest hurdle to operating cloud effectively. That is why we want to share our insights today on how you can be successful in unleashing your cloud operations team to realise the full benefits of cloud for your organisations. Now, we'll start by looking at the context of why organisational models are evolving and how systems operations teams can best respond and also benefit from them. Then we'll illustrate what these changes mean in practice by walking through two examples, provisioning and patching. So let's get into it. We first need a bit of historical context to better understand how organisational models have got to where they are today. Well, Frederick Taylor was a mechanical engineer in America in the late 19th century. He saw that the mainly craft-based working practices in factories at that time were inefficient, as they were focused on the individual or man, as he put it in this quotation. So he developed scientific management principles to address this by instead looking at the whole system. His solution was basically to divide the work between managers, who were the decision makers, and workers, who were the doers. Now, the managers, they rigorously defined and planned and supervised the work to be done and broke it down into separate standardized tasks for each worker. Meanwhile, the workers, they were chosen and trained to become functional specialists so they could carry out their allocated tasks over and over again. Now, we still see the influence of Taylorism in some modern management methods. For example, Six Sigma and lean management. These do work well where the desired end product can be clearly defined in advance and optimized, such as in manufacturing and mass production. And interestingly, we're now starting to see advanced automation breathe new life into Taylorism, with AI/ML becoming the managers and robots becoming the workers. However, knowledge work such as IT is different. The context in which we operate is increasingly dynamic, with business uncertainty, increased competition, more demanding customers, and the rapid pace of technology evolution, including cloud. Meanwhile, all of us crave greater autonomy, mastery, and purpose, as explained in Daniel Pink's bestseller book, Drive, all about human motivation. But if we continue to apply Taylor's functional silos and rigid processes to the IT lifecycle, this is what we get. Does it look familiar? We see there are multiple handoffs between teams, resulting in bottlenecks and delays, and a lack of shared accountability for the business outcomes. And we also get late discovery of the defects that are passed downstream, which results in rework. All of this hinders IT innovating and responding at the pace that businesses now require. So we need to move away from the influence of Taylorism. This means breaking down functional silos and reducing the need for coordination across the organisation in order to deliver value. It also means increasing autonomy and devolving decision-making out from managers to workers closer to their customers so they can innovate and respond more quickly. We achieve this by replacing functional teams with the concept of product teams. This is what we use in Amazon and also see in many of our most successful customers. Now let me explain. These are dedicated 7 to 8 person teams who are empowered to deliver specific end-to-end products throughout their entire life cycle. They may be external-facing customer products or internal enabling products. Crucially, the teams are autonomous and multidisciplinary, and they contain all of the roles and skills that they need. For example, design, development, testing, operations, security, all in one team in order to deliver value to the business. And they do this by prioritizing their own backlog of work to focus on their customers' goals. So while Taylor's functional specialists as cogs in a finely tuned system may have worked well in the past for predefined and stable environments, we find that these empowered autonomous product teams are much more effective in rapidly navigating and generating value in the dynamic technology and business environments we see today. And on top of that, they also provide much more intrinsically motivating environments to work in. So what does that mean for system operations? Well, this evolution to product teams does take time, and there will still be parts of the organisation that function in a more traditional manner, particularly where these teams are tightly coupled to specific technologies. These may be on-premises hardware or software, or in the cloud, for example, following a lift and shift migration. Here you will continue to have the traditional handoffs between teams, including infrastructure teams throughout the IT development lifecycle. However, there will also be pioneering product teams, refactoring existing applications and building net new full-stack cloud-native applications for their business customers. Or some of these teams may even be directly embedded within the business. For example, we often see this for digital experience web and mobile apps. These product teams will be reliant on Cloud Ops, not as a functional silo or gatekeeper, but as a true business enabler, providing automated self-service capabilities to facilitate and govern their use of the cloud. And this frees them up to focus on delivering value to their business customers. So, in response, we need to apply this product team approach to systems operations itself by transforming them into cloud platform product teams, each responsible for one or more cloud platform products. They need to create enabling products to serve their traditional customers and their new cloud-native customers, and of course the spectrum of other customer maturities in between. And I haven't shown all of these on this simplified diagram. It's this approach that will overcome the negative effects of Taylorism that we saw earlier. It will reduce manual handoffs and delays and give both the platform product teams and the application product teams the autonomy to build, automate and innovate in the cloud on behalf of their customers. It also gives traditional application teams an open door and pathway to start using more advanced cloud-native services just as soon as they are ready. So how do you get started with cloud platform product teams? Well, firstly, look at the cloud capabilities that you require and map them to separate products assigned to a product team. Then, each product team needs to work backwards from their customer, who are usually the application teams, in order to define and build compelling products. I'm now going to hand over to my colleague Stephanie Wynn to explain this in more detail and talk through what it looks like in practice for two example cloud products, provisioning and patching.
Thank you, Raoul. Hi everyone, I'm Stephanie. As Raoul previously mentioned, each product team works backward from their customers and provide customer-centric products. So how do you, as system and cloud operation teams, delight the application and development teams, your customers? It is first by understanding their cloud transformation journey. When application teams move to cloud and transform into product teams, these application teams progressively take on the full stack in order to increase their business agility and speed to market. That means they now have to make sure that both application and infrastructure are secure, reliable, and cost-efficient. However, these new operational accountabilities require time and prioritization. We are seeing two scenarios in organizations we work with. Either application teams trade off development time and business innovation to define their own operational standards. They spend time implementing the security, operational, and financial capabilities required to manage their cloud infrastructure and mitigate the organization risk. Or application teams want to focus on creating new features and product differentiation by spending more time on application development, leaving the business, financial, and security risk unaddressed. Both choices erode the application team's ability to sustainably deliver customer and business value in cloud. Therefore, it is important for the cloud platform team to provide a set of shared services and cloud products to assist the application teams in managing the full stack. The cloud products they create are centrally managed, automated with the required controls and governance to accelerate cloud adoption while keeping it sustainable and secure. By focusing less in managing infrastructure, application teams spend more time creating high business value while innovating and adopting cloud technology at speed and scale. Each customer's journey is different, and start by creating relevant operational products for their first cloud-anchored tenants. These products leverage a set of 15 AWS services, enabling governance and compliance with automated controls. Those services are split in 3 domains to help organizations provision, operate, and enable. There's a common set of products that we see customers build. The first one is provisioning, as you want your application teams to quickly adopt cloud for their business-critical and strategic workloads. Patching under operate is the second one, as it is often left to the application teams to understand how they need to patch their infrastructure in cloud, which introduces vulnerabilities and risk when application teams don't adopt best practices. These products will have to cater for different needs and application teams' profiles. For instance, digital experience teams working on web and customer-facing applications are more focused on product differentiations and therefore need agility and cloud-native services to accelerate speed to market. Their needs are different from the traditional teams, including those who manage mission-critical workloads like ERP systems. Those traditional teams need compute services with resilience, performance, and high availability. So there's no one-size-fits-all, and the central cloud platform product teams will need to be B-model to support both cloud-native and traditional teams and tailor their operational services to their needs. The cloud platform product team starts with the minimum lovable products, MLP. It starts small and impactful and ready to be iterated. In the next section, let's explore how provisioning and patching products can respectively leverage AWS services like AWS Service Catalog and AWS System Manager to meet the different teams' expectations. Let's see first how a provisioning product can be implemented in cloud. Application teams moving to AWS Cloud are now exposed to a broad choice of AWS services they can select. In a simple scenario where a development team wants a server to host their application, they may not know exactly which services to deploy and try their best to configure them correctly. Unknowingly, however, they could end up launching a version of a virtual machine that costs more than it should or leaves spot open, causing a security breach. So how can the Cloud Central product team help and assist the development teams in provisioning the right services to provide the required business agility with compliance and automation while minimizing organization risk? One recommended approach is building a product offering via a service catalog, leveraging AWS Service Catalog and AWS Cloud Formation. AWS Service Catalog allows organizations to create and manage catalogs of IT services that are centrally managed and approved for use on AWS. Products are quickly configured and deployed in AWS accounts using AWS Cloud Formation templates that allow you to model, provision, and manage AWS and third-party resources as code. The Cloud Platform product team enables the user's self-service catalog with a list of curated and approved products using a combination of AWS services, AWS Marketplace, and customer-based solutions. Next, they organize them into portfolio with version controls, give end users access, and add constraints and tags to ensure products are provisioned with compliance. When you, as the Cloud Platform product team, create these products, it is important they align with the application team's needs and expectations. For instance, you could create a foundation IT portfolio more tailored towards traditional teams who are mainly interested in database, storage, and compute infrastructure services like Amazon EC2. For the cloud-native team who are more working with full-stack and cloud-native services, you could promote services like AWS Amplify, that is a set of tools to accelerate the build of full-stack web and mobile applications. By promoting the right tool for the right job, you are moving away from an infrastructure provisioning function to become a true business enabler, accelerating business agility and innovation. However, when you create a product offering, it is important to make sure your products stay relevant and are successfully used. It starts by understanding the customer experience they provide. Application teams having a great user experience, for instance, the way they discover the product, the way it is configured, and the way it is operationally supported, will drive more usage and product adoption. It then gives an opportunity to the Cloud Platform Product team to implement mechanisms to collect and analyze feedback on usage and user experience. Based on these insights, the Cloud Platform Product team can then experiment and iterate on the product to improve the user experience, drive more adoption, and therefore help the application teams to create more business values. With this product lifecycle in place, we call it flywheel in AWS, the Cloud Platform Product team ensures that what they offer is relevant to the customers of cloud, and therefore constantly creates value inside the organization. Now that application teams have provisioned their first server, let's see how the Cloud Platform Product team can offer a patching service to assist application teams to meet their patching accountabilities. It is not uncommon to see organizations, after a few years in cloud, still relying on cloud tenants to manage their own patching, with no central team responsible for making sure tenants are patching with compliance. This can introduce vulnerabilities and increase the organization's risk exposure. When helping traditional and cloud-native teams with their operating system patching, we see two main types of scenarios. With traditional teams, similar to the way they operate on premises, their servers are managed like a unique system that can never be down. We call it mutable infrastructure, as it can be updated after being deployed to meet the changing needs of the business. For this type of infrastructure, the Cloud Platform Product team can offer an automated patching service. The process involves using AWS System Manager and Patch Manager to automate the patching of EC2 instances. AWS System Manager is a secure end-to-end management solution for hybrid cloud environments that helps you to safely manage and operate your resources at scale. Patch Manager is a capability of AWS System Manager. It automates the process of patching with both security-related and other types of updates. With cloud-native teams, their servers are rebuilt using automated CI/CD, continuous integration, continuous deployment tools. The infrastructure is designed for failure, disposable, and redeployed with the application. We call it immutable infrastructure. Once a change is required, the infrastructure is provisioned to the new requirement, and the old infrastructure is decommissioned. For this team, the Cloud Platform Product team can create a golden AMI, which is an Amazon machine image, standardized through configuration, consistent security patching, and hardening. It can also contain agents for logging and performance monitoring as approved by your organization. The Cloud Platform Product team can use EC2 Image Builder to create the golden AMIs. This fully managed service simplifies the building, testing, and deployment of virtual machine and container images for use on AWS or on-premises. Application teams take this golden AMI and redeploy the whole application stacks onto the golden AMI. Therefore, patching becomes part of the redeployment process and can be seamless, especially for application teams who have a high degree of CI/CD automation in place. Now, let's see the high-level automated patching process and how the responsibilities are shared between traditional application teams and Cloud Platform Product team. The Cloud Platform Product team is responsible for creating the patch baseline using Patch Manager. For each operating system, they select the mandatory patches to install. Patching will be applied on a schedule and by default, with application teams being expected to work this into their operating model. A specific schedule will be established per environment, development, test, production, and configured in Patch Manager. Application teams are responsible for testing the application in each environment after patches are applied to ensure no service disruption has been introduced. Most of the time, testing is manual and deployment in production is done via change request. If any service disruption is observed, the issue is mainly investigated by the application teams and supported by the Cloud Platform Product team. One potential outcome could be a patch exemption that could result in creating a customized patch baseline for a specific application team. Most importantly, the Cloud Platform Product team is responsible for reporting on the patching compliance and provides reports to the security and risk stakeholders involved in managing vulnerabilities. Now, if we look at the Golden AMI redeployment shared responsibilities, the Cloud Platform Product team builds the Golden AMI via automations using Amazon EC2 Image Builder, test and validates the AMI before releasing to the application teams. It is the responsibility of the cloud-native teams to use the latest Golden AMI when redeploying their infrastructure via CI/CD tools like AWS Code Deploy and AWS Code Build. With AWS Code Deploy, you automate your software deployments to a variety of compute services, such as Amazon EC2. And AWS Code Build helps you to compile source code, run tests, and produce software packages that are ready to deploy. Patching can then be fully automated as part of the redeployment process. If any service disruption is observed, the issue is mainly investigated by the application team. One potential outcome of the exemption process would be to create a customized Golden AMI for a specific application team. And similar to automated patching, the Cloud Platform Product team is responsible for reporting on the patching compliance, which is in this scenario reporting on the usage of the latest AMI with deployed application. Now, how do you start creating your first operations products? The Cloud Platform Product team needs to consider two dimensions while building cloud operations product. First, they need to support the business agility required by the application teams by offering products that are fully automated, self-service, so that the teams can quickly experiment, fail, learn, and iterate. But they need to do it with controls and compliance. There's often a misconception in IT operations model that organizations need to give up governance, security, and compliance for speed, automation, and innovation. But this is not the case in cloud, as we previously saw it with the provisioning and patching operations product. These two products enable self-service and automation with compliance and security policies by programmatically embedding the correct guardrails and controls. But sometimes when our customers hear about all AWS services, they find it too complex, and this perception slows them down from quickly understanding how AWS can help them achieve their business outcomes. Organizations are looking for clear prescriptive guidance to help them move quickly to the cloud with security, control, and safety. The faster organizations can optimize their IT processes for the cloud, the faster they can achieve their business goals. This is why AWS released AWS Cloud Ops. AWS Cloud Ops is a model and a set of resources for what enterprises need to do to build and operate securely and successfully in the cloud, no matter where they are right now in their transformation. AWS Cloud Ops is based on AWS depth of services and experience collected with millions of AWS customers who serve more than 1 billion of their end users. It provides the best practices and prescriptive guidance needed to understand how to leverage AWS management and governance services to achieve operational excellence and cloud adoption at speed and scale. AWS Cloud Ops is built at cloud scales from the beginning so that you can start small and quickly expand your operations. Now, let's look at the model. Similar to DevOps and SecOps, AWS Cloud Ops describes the roles, processes, and tooling for cloud operations success. AWS Cloud Ops helps customers enable, build, or operate their workloads in the cloud, on-premises, or at the edge. First, AWS Cloud Ops model makes it easy to set up a foundation for operations. Easily set up in minutes, it deploys guardrails and enables governance with controls. Second, Cloud Ops support bimodal IT operations, both traditional and cloud native, providing resilience and agility, whether you migrate, lift and shift, or refactor your application with microservices. And third, everything comes together in a central operations hub that can quickly respond to anomalies, out-of-compliance issues, and security alerts with pre-planned and automated actions. All of these capabilities are wrapped around the right side of checks and balances in terms of cost through the cloud financial management, and built on the back of automation and security, which is really job zero within Cloud Ops model. Now, we have a set of services that helps customers achieve each of these capabilities within their environment, like AWS Service Catalog and AWS Systems Manager, that is increasingly becoming the operations hub for customers to operate their environment seamlessly across on-premises and AWS. So why are customers choosing AWS Cloud Ops? Here are some benefits that customers shared with us. By operating on AWS, customers lower their cost of operations, improve productivity, achieve operational resilience, and when it comes to sustainability goals, have their carbon footprint reduced by up to 88%. Some customers who have leveraged AWS Cloud Ops are Netflix, Goldman Sachs, and Expedia. If you want to get more information on AWS Cloud Ops, go to aws.amazon.com/cloudops to get access to a broad set of free resources and solutions. Now we're coming to an end of this presentation, and here are some summarized concepts for you to take away. As we learned with Raoul, it is important to break down the functional silos to become a true business enabler. System and cloud operations teams need to evolve as product teams, working backward from the application team's goals and creating products that are customer-centric. These products are tailored to the team's operations mode and application type. Think how to support the evolution from traditional to cloud-native teams. Progressively, application teams will become more advanced in their use of cloud, and the Cloud Platform Product Team role will change from provisioning and managing cloud infrastructure to promoting innovation and business agility while maintaining security and compliance. Thus, your products will change over time. They need to iterate by having the product team owning its lifecycle and ensuring it constantly creates value to the customers of cloud. This is how you become a true business enabler and help your organization to maximize the cloud benefits, like business risk reduction, cost efficiency, or business agility. And remember, you can't do it all, so don't try to boil the ocean. Becoming a central cloud platform product team is a journey. It doesn't mean you need to create many product teams. Start with a small cloud team and quickly deliver business outcomes by shifting to a product mindset and working on capabilities and services which will turn into key products. And accelerate by leveraging a set of best practices and prescriptive guidance, such as AWS Cloud Ops. If you want to know more about cloud operations, like how to automate your operational readiness for the cloud or enhance your application observability, We have some very interesting and insightful sessions in the Systems Admin track. If you want to deep dive more on patching, you can join the Sec4 session, Patch It Up Strategy for Successful Vulnerability Management, in the security stream. No matter where you are in your cloud adoption journey, building your cloud skills is an important activity for improving your cloud operations maturity. Here is some content for you to explore. And as you build your skills, consider preparing for one of our 11 AWS certifications. The AWS SysOps Administrator certification has a specific focus on cloud operations. Thank you for joining this session. It was a pleasure to share with you some insights on AWS Cloud Operations. Thanks for watching. Don't forget to complete the session survey, and I hope you enjoy the rest of the summit.